Representing aqueous reactions. There are three different types of chemical equations. The molecular equation is what I think of as the regular chemical equation. That's going to show the complete neutral formulas for each compound in the reaction as if they existed as molecules. So here's an example. 2 potassium hydroxides plus magnesium nitrate react to form 2 potassium nitrates in solid magnesium hydroxide. But these aqueous things, when you put them in water, when they're dissolved in water, those ions separate from each other. So an equation like this is very useful, but it's not really describing what's going on in that beaker. So the complete ionic equation shows all the species as they're actually present. So it's going to show the potassium ion separate from the hydroxide ion, the magnesium ion separate from the nitrate ion. And as the products, the potassium and the nitrate are going to be separate too. But this solid compound, the magnesium and the hydroxide really hit it off and they precipitated. They did not dissolve, and so we represent that with its neutral formula because it's a solid sitting on the bottom of the beaker. So complete ionic equation shows everything. The net ionic equation. This word net, I did our taxes yesterday, which, you have to look at W-2s and you look at your paychecks and stuff. And there's your gross pay and your net pay. What's the difference? A lot. They take all kinds of stuff out, right? There's FICA and Social Security and Medicare and taxes and taxes and taxes, right? The net pay is what they actually give you after they took all the other stuff out, right? The net ionic equation, we're going to take out everything that doesn't actually react. They're called spectator ions. They're at the party, they're mingling around, but they're not participating in the reaction. They are not part of the couple in the back porch necking, okay? So that's what a net ionic equation is. This shows the species that actually change during the reaction. So to write a complete ionic equation, you have to start with a balanced chemical equation, a molecular equation. You're going to write all of the aqueous ionic compounds as ions, individual ions. This includes aqueous, strong electrolytes. So that'll be soluble salts, the aqueous ionic compounds, and the strong acids. And I know we haven't gotten to the list of strong acids yet. I don't know why they haven't shown it to us yet, but it is coming. And the strong bases. Then if there are solids, liquids, or gases, you don't do anything to their formulas. You just copy them down. Because they're not separated into ions. They are actually as their molecular formula indicates. These include insoluble substances, weak electrolytes, and non-electrolytes. We know that a weak electrolyte does ionize a little bit, but what is it mostly present as? It's mostly present as the intact molecule, and so that includes the weak acids. So here's an example. Lead-2 nitrate plus potassium chloride yielding lead-2 chloride and potassium nitrate. The lead-2 chloride here is insoluble, because lead-2 is one of the exceptions to chloride compounds being soluble. So this is an aqueous ionic compound, so we're going to write it as the individual ions. So we've got Pb2+, and there's 2 of the nitrate ions. One of these, when it comes apart into ions, gives us 2 individual nitrate ions. It's like you had a bicycle, and you took the wheels off, right? Do you get one bicycle frame and 2 wheels that are stuck together? No, the wheels are separate. So I see these nitrate ions as being like the wheels on a bicycle. It had 2 wheels. You take them off, you have 2 wheels. Here at KCl, here I have maybe 2 unicycles. 2 unicycles, I'm going to get 2 seat frame assemblies and 2 wheels. Okay, so it comes apart, but I started with 2 of them. Lead chloride is insoluble. The lead and the chloride got together, and they're not separating from each other, and they're just going to sit as a solid on the bottom, so we don't do anything to that formula, we just copy it down. And then this one's aqueous, and so we're going to separate those. There's 2 potassiums and 2 nitrate ions. If you're careful with looking at subscripts and coefficients, when you copy this down, it should be balanced. Go ahead and look at it anyway and make sure that it is. Any questions about complete ionic equations? We rarely actually use complete ionic equations. The reason we need them is because you have to look at that before you can write the net ionic equation. So in that complete ionic equation, we have some ions that are called spectator ions. So in the reactants, I had 2 nitrate ions, and in the products, I have 2 nitrate ions. I have 2 potassium ions in the reactants, 2 potassium ions in the products. Nothing happened to them. It's like going to a boxing match and you watch the 2 guys in the ring beat each other up. If you're sitting in the stands, do you leave with a bloody nose? Puffy eye? Not unless things got really out of control and the whole stadium got into a fight. That's not supposed to happen. You're a spectator, nothing happened to you. So these guys came in and left completely unchanged. They're spectators. Does it really matter that they were there at all? Not really. What matters is that lead, too, and chloride were there. They got together and made a couple. They made a solid. So we just cross those guys off. Just cross them out. And the net ionic equation, you just write down everything that you didn't cross off. So this is the net ionic reaction. What if we had, instead of nitrate ion, what if we had, I'm blanking, acetate ion? Would that make any difference to what happened? No, because all acetate compounds are soluble as well. It's not going to make a different precipitate. So these spectator ions are needed because they balance the charge on the incoming ions, but they're not actually part of the reaction. Any questions? Consider the following reaction occurring in aqueous solution. Write the complete ionic and net ionic equations for this reaction. We need to separate into ions pretty much everything that's aqueous. We need to be a little careful with acids. This is so annoying. Where is that? I know I saw it in here. Yeah, it's kind of hiding in here. They're not doing a real good job with this. These are the strong acids. There's 6 of them. These guys right here. So you need to memorize those. It's HCl, HBr, HI, nitric, sulfuric, and perchloric. Those are the strong acids. When you put those into aqueous solution, they ionize completely. So there's 6 you memorize. Any other acid is a weak acid. So hydroiodic acid is in that equation we're looking at. And so it's a strong acid. We're going to separate it into ions. Okay. So this is an acid, but it's a strong acid. So we're going to separate that into ions. What are the 2 ions that are present there? For acids, it's always going to be H plus and another ion. So it's going to be H plus and I minus. And barium hydroxide, what are the ions that are present in that compound? I'm asking a lot of rhetorical questions, I think. Barium 2 plus and hydroxide. It's very important to remember that as far as Chem 1A is concerned, you only have two ions. One's positive, one's negative. We're not going to do anything like this where it breaks into three ions. Those compounds do exist, but we can ignore them in Chem 1A. We're not going to see them. Are we going to separate H2O into ions?
No.
Why not? Because it's a liquid. If it says L, S, or G, leave it alone. And here's barium iodide, and that's got ions. It's an aqueous ionic compound, and so those are its ions. It's helpful to just write those down before you get, distracted by the whole equation business. So those are the ions we're looking at. So the complete ionic equation. These tend to be kind of long, so write small and give yourself plenty of room. So this has two of these HIs. That means I'm going to get two H's and two I's, and I need to write them separately. So 2H plus, and those are aqueous, and 2I minus, aqueous. And then barium hydroxide, each of these, 1 mole of this has 1 mole of barium ions and 2 moles of hydroxide ions. So I'm going to get Ba2 plus aqueous plus 2OH minus aqueous. And then my arrow, water's a liquid. I'm just going to copy it down without doing anything to it. And then I have another ionic compound that's soluble, and that has 1 barium ion per unit and 2 iodide ions. Any questions? If you have a good understanding of what these formulas mean, then writing this out will be very straightforward. If you're a little confused on what's going on up here, it's going to make this difficult. So you need to go back to chapter 3 and get that straightened out. Ask for help if you need help. So there's our complete ionic equation. The net ionic equation, we're going to look and see who didn't change. And we're going to cross those guys off, because those are spectators. They were just hanging on around and watching what happened. They didn't get involved in a relationship. So what's one of the spectators? The iodide. There's 2 iodides there and 2 iodides there. Nothing happened to iodide. What's the other one? Barium ion. So then for the net ionic equation, we're just going to copy down what we didn't cross off. 2H plus aqueous plus 2OH minus aqueous, yielding 2H2O liquid. Now what's not quite right about that? There's coefficients of 2 in front of all the reactants and the product. I could get rid of the 2's and it would still be balanced, wouldn't it? Ideally, your balanced chemical equation should have the lowest ratio of coefficients. And so the best answer here would be to erase the 2's. Any questions?